Okay, so we're in section 3.4 of Math 146. Today we're going to focus on trig graphs, specifically the sine and the cosine curve. So let's do a little bit of a review of what the sine and cosine curve look like. So the sine curve, if we were to graph, say, sine of theta, in general has this shape. And what you see right there would basically be one cycle or one period of the sine curve. Now the sine curve continues on forever, and it's going to keep on going. And I'm going to dot this, even though technically it's the same thing. I mean, it's all part of the curve, but it keeps on going forever, and it goes on forever in both directions. Just the solid part there represents one specific cycle. Again, one period of the sine curve. Let's go ahead and also take a look at the cosine curve. So cosine of theta. And cosine of theta looks very similar. And what you see there in the solid green represents what would be one cycle, or again, one period of cosine of theta, but very much just like the sine curve, it keeps on going forever and repeats its pattern. I probably could have done a slightly better job sketching that cosine curve at the right-hand side there. I'm having a hard time making this curve. There we go. It's a little better. Anyway, so what you have there is, again, one period of each one of them. So that should be somewhat of a review. Hopefully you've seen that before. If not, this is your first experience with it. There are some key components that we need to know in order to know the sine and cosine curve. Now, the one nice thing is you should be able to look at them and say, well, they basically look like they're the same thing. And if you say that, then you would be accurate. They are really basically the same curve. They're just shifted. Sine and cosine are shifted, basically what would be pi halves units away from each other in a standard sine or cosine curve. So again, there's some key components here. What you should see is that each one of these curves has a maximum. It's got a top value and a minimum. It's got a bottom value. In both cases, it's got a maximum and a minimum. And each one of them is basically a cyclical wave that's going to keep on going. What they each also have are what is called a midline, which basically is the center that kind of makes the, I don't want to say symmetric, but it makes the space above the curve and the space below the curve the same. So they each have a midline. And when it comes to writing the equations and writing the values of these things, knowing that's going to be important. Now, all the values that lie on these curves are going to correspond to what we talked about with the unit circle. And this is where the nice connection comes in. If you remember from the unit circle, if the angle, and this is actually going to be, and I know that sometimes the book uses x, this is going to be your theta axis. Basically, this is representing your angle. And then you're going to basically have your y value still here, your output. The sine of 0 was 0. Well, that's right here. The sine of pi is also 0. Well, pi just happens to be right here, so we're going to call that pi. The sine of 2 pi is also 0, and this is all straight from the unit circle. The sine of pi halves was 1. Well, pi halves, of course, is right in between 0 and pi, and your value, y value there is 1, so this goes up to 1. And then the sine of 3 pi halves, which is here, is -1, so that bottom value down there is a -1. These are the important values here. These are actually what are called the well, actually, I'm not even sure if there's a specific name for them, but they are kind of the five most important values when it comes to sketching a graph. If you kind of know those five things, you can make a really good sketch, because what you've done is you've gone from what would be considered the midline in the center up to the maximum, back down through the midline to the minimum, and then back to the midline. That completes one full cycle, and then the process just literally repeats over and over again. The same general idea is going to happen with cosine. Again, the top and the bottom are going to have values of 1 and -1. So when cosine of, or the angle is 0, cosine's value is 1. Cosine is pi halves, which is right there. The y value is 0. Cosine at pi is -1. Cosine at 3 pi halves, which is right there, 3 pi halves, has a value of 0. And then back to the beginning, cosine at 2 pi repeats its value of 1, goes back up to its maximum. So again, maximum through the midline to the minimum, through the midline, back up to the maximum, right there at the top. So knowing the shape of these waves is also helpful. This might actually help when it comes to learning some of the unit circle values. If that's not as easy for you to do, then maybe knowing this is going to be a little bit easier to do. Of course, all the values in between as well. You've got your 30-degree and 60-degree angles, or in radians, your pi thirds and your pi sixth angles that are going to correspond to different points along the curve that'll basically draw out the entire curve. So if you were to traverse around the unit circle, it would sketch out one of these graphs, or one full cycle of this graph. All right, so both of these curves are what are called sinusoidal. Sinusoidal in shape. Basically, it just means that it's going to form the sine wave. And again, one of them is cosine, the other one is sine. I understand that, but they're both called sinusoidal when it comes to the shape, because again, they are the same wave, just shifted a little bit. Now, your book uses some slightly different notation that I'm used to, and I will try my best to use the notation in there, but each one of these graphs follows a basic, not basic, but this is the idea. You've got A sine of, now I call it bx plus c, excuse me, that should be minus c, plus d, where A, B, C, and D all do some kind of shifting and other information to your sine and cosine curve. Your book, I believe, instead of using a B, they use the Greek letter omega. So I'm going to change it for that purpose to omega. I don't even know that they technically use a letter for the C and D part. So I'm going to leave that in there and explain what all this stuff is. So again, your book has it as y equals A sine, and they use omega, which looks like a W, x, and then I'm going to leave minus c and plus d, and I'm going to explain what all these different pieces are. Capital A is what is called the amplitude. And the amplitude is literally going to be the distance from the midline to either the maximum or the minimum, because it should be the same distance since the midline is in the middle. So the amplitude is the distance from the midline to the max or min. And it is a distance, which means that it is going to actually always be positive. I don't care if there's a negative out in front or not. The amplitude will always be positive. Always positive. That's horrible. Positive. we'll explain what actually happens if there's a negative out in front when we get to that. And again, amplitude, if you think about it, again, amplitude is a distance from the midline to the maximum or the minimum. Just kind of tells you how far up and down these curves are going to go. For a standard curve, the ones that you can see that I've sketched on the paper, the amplitude is both 1 because there's nothing written out in front of sine or cosine, so the amplitude is 1, which is why from the midline up to 1 or from the midline down to -1, the distance is 1. The omega part has to do with your period. So we'll just put, for right now, will affect the period. Okay, it is not actually going to be the period, but it will tell you some information about how to find the period. And the period is how long it takes for sine or cosine, or any curve for that matter, to get back to its original starting point, to basically complete one full cycle. I shouldn't say get back to the starting point, but to complete one full cycle. And the way you're actually going to be able to figure out the period is you're going to, for sine and cosine specifically, you're going to take 2 pi and divide it by omega. So your period is going to be 2 pi divided by omega. Right now, each one of them has a period of 2 pi, because if you look where sine starts, it starts here at 0, goes all the way through its cycle before it starts to repeat, and it takes it 2 pi to do that. Exact same thing with cosine. I'm not going to trace back over it again, but that's what that is. The C value, and I actually have to correct myself. I'm going to go back and correct my formulas just in just a second. But the C value will shift left and right. This is what is known as a phase shift. Phase shift. So as it stands right now, if C is positive, it will shift to the right. If C is negative, it will shift to the left. Now be very careful, because this right here is already a negative value here. So it says omega x minus C. That means the C value would actually be positive, even though you'd look at it and be like, oh, it's minus C. You're subtracting a positive value. So C is positive. So a positive C will shift it to the right. A negative C will shift it to the left, however many units. Now, I'm going to fix something before I get to D, and that's the placement of my parentheses. So there's actually nothing wrong with the way I wrote this, but in order to actually figure this out, you basically have to factor out the B, or in this case, the omega, excuse me, from that parentheses. So what I mean by that is this. Your actual function should look something like this. It'll be the sine of, and then you'll factor the omega out, x minus, and then technically, the other part would be C over omega, because you factored it out of there. So all of this is still part of the angle of sine. That omega times x minus C over omega. Where really, and I'm going to fix this part, it's C over omega that's going to end up being your shift. And then let me go ahead and put the plus D on here. Oops, let's put that back in blue. And again, when we do the examples, I think you'll be able to see this. But basically, you need that x isolated, or your theta, or whatever you want to call that main part of your angle in there. You need that isolated without having a coefficient attached to it. If you have that coefficient, we have to factor it out, especially if you have a phase shift, some kind of a C value in there. And then the last part is probably the easiest one. That's your D value. D is a vertical shift. It's literally going to shift the entire sine or cosine wave up or down however many units. If d is positive, it goes up that many units. If d is negative, it goes down that many units. And d will also shift your midline up or down exactly the same thing. And as a matter of fact, d tells you what the midline is. So d is your vertical shift. It's also the midline. And then the only other thing that we hadn't talked about so far, like I said, was, well, what if there is actually a negative value out in front of your sine? So that a value, the amplitude, is actually a negative. Well, again, the amplitude is going to be a positive value no matter what. But if there happens to be a negative a value, and I'll write this down here, a negative a value will reflect the graph over the x-axis. So that's what a negative a value. The negative actually just takes the entire sine or cosine function and reflects it over the x-axis, or over its midline, I guess you should probably say. If the whole thing has been shifted, then the x-axis will no longer be the midline. So that's the basic shifts. That's the idea. We're going to have to put all these things together in order to be able to figure this out. So what we're going to do is we're going to do some examples where basically you have to look at what's written and determine what the shifts are, and then we're going to sketch the graphs based upon those shifts. And then in the other part, we're going to take a look at a graph and see if we can actually write the equation based upon what we see in the graph. All right, so let's do a couple of examples. All right, example 1. Let's say we are given y equals 3 sine of x. And all we want to do is figure out what shifts we have and how would we sketch a graph of that. You have to be able to at least sketch one full cycle. So the only thing that I can see there that I have is I have an a value out front. I don't have anything that's multiplied times the x. I don't have anything being added or subtracted with the x, or outside of the entire sine function. So the only thing I have is that a value, which means that I have an amplitude. Oops, don't want that in black. The amplitude is going to be 3. So really all that's going to do is it's going to stretch the sine function up and down so that the maximum now is 3 units away from the midline, and the minimum is 3 units away from the midline. The sine function will start in the same place. It's going to start at 0. And again, you really need 5 values. For a basic sine curve, you're going to need to have the 5 values. You need to have 3 on the midline, 1 max, 1 min. All right, well, it hasn't been shifted left or right or up or down. It's been stretched, but it hasn't been shifted. So 0, pi, and 2 pi are still all going to lie on the midline, which is still 0, again, because it hasn't been shifted. But now instead of the maximum being at 1, it's going to be up at 3. And that's going to occur at pi halves. Instead of the midline, instead of the minimum being at -1, it will now be at -3, which will occur at 3 pi halves. So this will be a nice sketch of your sine function. That's not very good. Nice sketch after all. Should be a smooth curve, not pointed like the one I did. That's much better. That's 1 period from 0 to 2 pi. We should usually label that 0, pi halves, pi, 3 pi halves, and 2 pi. And then that's 3 and -3. Those are all things we should always label so it's not up to interpretation, and you can definitely tell that that's what that is. All right, so that's the only shift that we had there was an amplitude shift. So now let's say, for example 2, that we have y equals, let's say, negative sine of 2x. Well, now I have something being multiplied by my 2. That's kind of that omega value that they were giving us. So what that's going to tell me is that's going to affect the period, or how long it takes for this graph to get through one full cycle. So I know that the period, according to what I've said before, was 2 pi divided by that omega value. So the period is 2 pi divided by 2, because 2 is the omega value there. So the period simplifies to just pi, meaning it's only going to take pi units to get through one full cycle. Well, if that's the case, again, going back to my basic sketch, I know that it still starts at 0 because there was no vertical shift, there was no phase shift. It's still going to have to hit 3 points on the midline total. But now the difference is it's only going to take pi to get through the whole thing. So this one out here is actually pi. This one's still 0, which means that the one in the middle is actually going to be at pi halves. And then I've got to figure out where the max and the min values are going to be. Well, halfway in between 0 and pi halves, of course, is pi fourths. And then halfway between pi halves and pi is going to be 3 pi over 4. And the only other thing that I've got here, let's see, it's got a amplitude of 1 because it's technically a negative out front, so it's just a -1, but the negative is going to flip it over. It's going to reflect it over the x-axis. So that's going to be at 1, that's going to be at -1. Instead of going up to its maximum first, it's going to go down to the minimum. So it's going to start there, but then at pi fourths, it should be at the minimum. And then at 3 pi fourths, now it should be at the max. It's going to flip the entire thing over. So now the function, sketch, looks something like that. So the period now changed to only pi units. The amplitude was still 1. There was no vertical or phase shift, but the period was pi, and it did flip or reflect over the y-axis because of the negative value out in front. All right, and I think in both of these examples, especially the first one, but even in the second one, it was pretty easy to figure out what the increments were if you have some kind of period other than 2 pi. But let's look at one where maybe it's not quite so easy to see. So let's say that we have y equals 3 sine of 4x. So this one has an amplitude of 3, which means it's going to go 3 up and 3 down from the midline. And in this case, it's going to have a period of 2 pi over omega, which is 4. That, of course, reduces to pi halves. So what you would have to do is you would have to figure out, okay, I've got this sine function. It's going to start at 0. It's got to go out to pi halves. Well, you could certainly do this one by simply cutting pi halves in half, figuring out what the middle piece is there, and then cutting each one of those in half. But the general idea is, because you really want to have 4 equal sections, if you kind of look at the graph that I had above, this is split into 1, 2, 3, 4 equal sections, right? 1, 2, 3, 4 equal sections. Then basically, to figure out what you're going to count by, you're going to take the period and you're going to divide it by 4. So if you take pi halves and divide it by 4, well, dividing a number by 4 is the same thing as multiplying by its reciprocal, so that would be pi halves times 1/4, or pi eighths. So that would really tell you what you're counting by. So I know, again, I'm going to have 4 equal sections. So the first one would go from 0 to pi eighths. 2 pi eighths is pi fourths. 3 pi eighths is 3 pi eighths. And then 4 pi eighths, of course, is pi halves when you reduce it. So that would be how you would set this up to count. And then, I'm not going to do a really great sketch here. We know that the amplitude is 3, so it's going to go up to 3 when it hits its max, down to -3 when it hits its min, and come back through the center right in the middle. So it would look like that. So that's how you would figure it out if you had some kind of a strange period of some kind. And that's going to happen where the period is not always the easiest thing to figure out. And again, you're always going to use kind of the 5 key points here to be able to figure this thing out. All right, we'll do one more example on this video, and then we're going to come back with a second video because we haven't done anything with phase shifting or vertical shifting yet, and that's what we'll do on that one. For this last example, I want to do one that looks like this. So y equals 2 sine of negative pi halves x. So it's definitely got an amplitude of 2. And once again, to find the period, you're going to take 2 pi and divide it by the omega. Well, the omega in this case is negative pi over 2. And you might say to yourself, how can I have a negative period? Because this is going to end up giving me a negative period. And you really can't. What you have to realize here is that sine is an odd function. So if you kind of scroll back up here to where I put the entire sine function up here, sine is an odd function where it means it is symmetric to the origin. If you rotated that entire thing 180 degrees, spun it around the origin, it would be exactly the same thing. And again, by looking at it, cosine, which we haven't really dealt with too much yet, is an even function. It is symmetric to the y-axis, or in other words, if you took the entire thing and folded it over the y-axis, it would lay flat on top of itself. So because sine is an odd function, this goes back to our even and odd stuff, we could actually write this equation as -2 sine of pi halves x. Do not think of this as factoring out a negative, because that's not really what you're doing. You're using the fact that sine is odd to know that if I were to input a negative in here with an angle and get out a positive, well, if I input the positive, I should get out a negative. That's what the odd part of this means. So you can rewrite it. And it's easier to see from this one because I now know, okay, the amplitude is still 2. The negative out in front is just going to reflect this thing over the x-axis, and now I can actually figure out the period and eliminate that negative sign where I had it. All right, so 2 pi divided by pi halves. Again, that's the same thing as saying 2 pi times the reciprocal, which is 2 over pi. And what you should see here is the pi's will cancel out, and that actually leaves me with a period of 4. That's interesting because it doesn't have pi in it. But remember, it doesn't always have to have pi in it. As a matter of fact, this makes things a little bit easier when it comes to sketching, because if I want to sketch 4 equal units, 4 equal spaces, and I've got to go out to 4, out here is 4. Well, that's easy. I'm going to count by ones. So that'll be 1, 2, 3, and 4. And let's see, what do we know? We know that this thing has an amplitude of 2. And it's going to be reflected. So instead of going up first from its midline, it's going to go down to the minimum at -2, back through the midline, up to the maximum, and then back down to the midline. So it's going to look something like that. All right, we are going to come back with a second video on this one. We'll try to incorporate some cosine in here as well. But we're also going to talk about vertical and horizontal shifting in the second video. Put it all together.